Okay, guys, so today we are going to be moving into population. Now, the cool thing about population is we're still going to be using the same compound interest formula because you got to remember the compound interest formula is used to determine future growth or future decay. So it can be used for money, but it can also be used for population, and we will dive into that. So example 1, Blueville has a population of 7,000. Its population is increasing at a rate of 1.4%. What can we predict the population to be in 10 years? So first things first, we are still going to lay out our variables. And A, we do not know. That's what we're looking for, what it will be in 10 years. Our P, our initial population, is 7,000. Its population is increasing at a rate of 1.4%. And if you were to convert that into a decimal, it would be 0.014. And remember, if you're just trying to convert that to a decimal, you just divide the 1.4% by 100. And then the N, almost always when we're talking about population, the N is going to be 1 because it's counted every year. It wouldn't really be kind of difficult to sit there and count population, monthly or weekly or things like that. So it's going to be once a year. And then T is going to be 10. So as you can see so far, same exact process as we had when we were talking about money. So now we just have to fill in our compound interest formula. So we do not know A. P is 7,000. 1 plus 0.14 over 1 times 10. So now, as you can see, it is exactly the same thing. We're going to get the same type of formula. The only difference is we're talking about population and not money. So now we go to our calculator. So we'll clear this out. So we have 7,000. 0.014 on top, 1 on the bottom. We're going to raise it to 1 parentheses 10. And so as you can see, your answer is going to be 8,044.102391. Now, we got to think about this because we are talking about people here. We're not going to have a decimal. We're not going to have 0.1 of a person. So the answer to this is going to be 8,044. So our A is going to be equal to 8,044 people. So hopefully that makes sense to you. We can't have 0.1 or 0.2 or 0.25 of a person. So just keep that in mind. We're going to be rounding all of these to the nearest whole number. So now let's look at our second example. And so with the last one, we had population that was increasing, but we can also be tracking our population that is decreasing. And what we refer to that as is decay. So you have growth that is positive, and then you have decay. So let's go ahead and take a look at that. So once again, go ahead and list out your variables. And so the A is what we're looking for. What can we predict the population to be in 20 years? So we don't know that one yet. P, Oakville has a population of 16,000. 400. It is decreasing at a rate of 1.3%. The N, once again, we're going to be counting that about every year. So it's going to be 1, and T is 20. So now we are just going to plug it into our formula. So we do not know what A is. P is 16,400. And it's going to be 1. And now this time, because it is decay and it says that it is decreasing at a rate of 1.3%, so therefore we know that we're going to be subtracting the 0.013 over 1. And not adding it. So then we have 1 parentheses 20. So this is the key for the decay here. We got to make sure that we are subtracting when it is talking about a decreasing rate. So we've got to have a minus inside that parentheses. So now we're just going to go back to our calculator. And so we have 16,400 parentheses 1 minus the fraction 0.013. Oh, go back up into my box here. 0.013 over 1 outside. Raise it to 1 parentheses 20. And so now we get 12,623.7. But remember, we are not dealing with decimals here since we are talking about human beings. So we are going to round it up, though, because the 7 is larger than 5. So our answer is going to be 12,624. That 3 is going to get rounded up. 20, was it 24? It was. So A equals 12,624 people. So that's how that one works. You will have 2 of each of these tonight. So please just make sure, or today, not tonight. So please just make sure you are reading them carefully. Remember, if it's decreasing, we're going to have that negative inside the parentheses. And if it's obviously increasing, you just continue on with what we've been doing. So hopefully you guys pick up on this. It is pretty much just an extension of the compound interest formula. However, you can now see that we can use that same formula to predict population. So if you have any questions, please let me know. And I hope you guys have a great day.